as I was putting the first example on the board, I realized, I did prove that the standard form, or one of the 4 standard forms equations, is a conic in my last theorem. So can I just put it a little down? So I never came up with equations in my derivation. I was just proving all the information I gave you got a conic section. But let me come up with the standard form for the equation. Getting rid of fractions. Bringing all the r's to one side. Isolating r. Here is one of my 4 standard forms. With the second standard form, that was subtraction operation, it just goes in the other direction. If this changes to sign, stays positive, the curve is going to look like this. And the subtraction operation goes down. So my apologies, I forgot to mention that. Now let me dive into my first example. So notice that this is not one of my standard forms, because that's not a nice clean constant one. And so rewriting. Now clearly this is in standard form, and my eccentricity is 1/2, which means I have an ellipse. But it's just easier for me to use the original equation because it involves those fractions. So if you don't mind, now that I've established I've got an ellipse, let's get rid of this. And let me impress upon you how darn easy it is to sketch the polar graph of this equation. It merely comes down to finding intercepts. So here I go. Planting my feet at the pole, looking straight at the positive x-axis, or looking down at the negative x-axis. Look in the direction of 0 or pi. The sign is going to be 0. My radial distance is simply 2. Here are 2 x-intercepts. I'm laying my points polarized. Now, standing at the pole, looking straight at the positive y-axis, that is to say, look in the direction of pi halves. The sign of pi halves is 1. My radial distance is 4. Looking from the pole straight down the negative y-axis in the direction of 3 pi halves, this is -1, and my r value is 4/3. I know it's an ellipse, so I think it looks something like this. One of the foci is located at the origin. But notice how this focal point is 4/3 away from the associated vertex. So the other focal point is going to be 4/3 units away from the associated vertex. And therefore, does that give me 8/3? There's a polar representation of the other focal point. So in my picture, I've identified all 4 intercepts and the location of 2 foci.